anything. Okay, there it is. All right. So we're looking at 5.2. Is that right?
Yes, that is correct.
Okay, which question do you want us to start with?
Number one, please.
Number one. Okay, so graph each equation. All right, so if you're seeing my screen, you see the problem y f of x equals 3 to the x. We know this is a growth function because the the a the a here is greater than 1. So we know it's going to do something like that. To do this correctly, sometimes they just want a general shape, but you should really make a table here like x and y. And you first want to go wherever the exponent is 0. In this case, it's just at 0. So anything to the 0 power is 1. Then you want to get another point. Usually it's where the exponent is 1. 3 to the 1 is 3. And then so on. So like you can put 2 in and get 9. Negative exponents, you have to do a little bit more to figure that out. But we have enough points here to be able to graph this. We got 0, 1, 1, 3, and then 2, 9 all the way up here. 4, 5, 6, 7, 8. Start right there. But it you can see it grows really quickly.
Okay, I see.
Now, negative 1, 3 to the negative 1 power, you have to remember the properties of negative exponents. Anything to a negative exponent, you flip it, or you put 1 over it to that positive exponent. So this is 1 over 3 to the power of 1, or just 1/3. So a lot of detail on that. I mean, it's helpful for the next ones. Potentially, are we going to 3? Is that next?
Yeah.
Okay.
Number 3.
All right, let me get that snipped in here. So this one it's kind of the same thing. I mean, you know because a to the x, because that a is less than 1, it's between 0 and 1 actually, that it's some sort of a decay, and we see that from the table here. So we'll do the same thing we did before, x and y here. If you put it to the 0 power, you always get 1. This is 1/3 to the 0 power. If you put 1, you get back itself. 1/3 to the power of 1 is itself. Negative 1 is the next exponent, because when you put anything to the negative 1 power, it flips it, so it becomes 3 over 1 to the power of 1.
Sorry about that. My
Jack
was not working.
Okay, well, this is recorded, so I mean you'll get it later. I was just going through the next one here, where we've got some negative exponent stuff happening, and so like negative 2 is 1/3 to the negative 2 power. What that means is you're going to flip it 3 over 1 to the power of 2, which is 9.
Oh, okay. I see what you mean. So you got 3 over 1, 3 over 1.
Okay, so again, you just need enough points that you can graph here. Like I would probably want 5 if I were grading this, but usually 3 is the minimum they accept for this.
Mm-hmm.
So I mean, you can obviously make your axis over here. I don't know how accurate it needs to be, but 1 1/3, negative 1 3, negative 2, 9 is way up here. So it again comes this big downward decay thing. Okay. How about number 5? Is that the next one?
Yep. Oh wait, no, my bad. This one's 3 through 9 now. So on to number 4, please.
We didn't do 2. I hope that's not. Do we need to do 2?
That one's not required.
Okay.
Thank you, though.
Which one? Number 4?
Yes, please.
Okay. All right. So number 4. I mean, it's very much like number 3. You're going to make a table. It's a decay function because the base a, which is 1/4 here, it's less than 1. So we know that it's going to be a decay thing. So the table, again, this is kind of where I think you cut out. You always start by putting it the exponent of 0, and it always returns 1. When you put 1 in, it returns itself. And then the question is, where do you go from here? Now, it seems odd, but you're going to actually go to the -1 power because that flips it and makes the exponent positive.
Oh.
So that becomes 4. -2 power is 1/4 to the -2 power. It flips the inside to the power of 2, which is 16. Again, these are hard to graph, but you're going to get something that looks like that. We can call that that's our origin, I guess, on there, 0, 1.
Alrighty.
Something like that. What's the next one to go to?
Number 5, please.
5. So number 5, it says 4 to the x equals 2. So the goal here is to get the bases the same. And you're either going to go 4 to 2 or 2 to 4. Usually you go to the smaller base. So 4 can be written as 2 squared to the power of x. And then when you have an exponent of an exponent like this, you can multiply them. So it's 2 to the 2x equals 2. The exponent over here is 1. So that's 2x equals 1. X equals 1/2. Yeah, you got it.
Perfect.
Very much have it.
All right, what do we do now?
That's it. I mean, that's it for that one. What's the next one to do? 7?
Oh, just solve it. My bad.
That's
All
it.
right,
Yeah.
number 6, please.
Number 6. Okay, so number 6. Scroll down here and get us a little more room in our.
Just do like 5 to the. Let's see. So 5 squared is 25. 5 to the third is 125.
5 to the third is 125. You can multiply the exponents. Set the exponents equal. Divide by 3.
So 3x equals 1. Oh, I see. All right. So x equals 1/3 in this case. All right. On to number 7.
So number 7 is 1/2 to the power of x equals 4. So
this need to be -2 on the right or something.
You're going to change both of these. Usually you want to try to only change one. Like 1/2 is really 2 to the -1 power.
Oh.
And 4 is really 2 squared. I mean, that the whole game here is can you figure out what the right base should be?
Oh, so now I get it back x equals 2, and then divide by the -1, divide by -1, and x equals -2.
Yes.
All right. On to number 8.
Great. Okay. So this one is a really good question, but it's if you don't understand any of the things we talked about, you'll just think it's impossible because you have to change both of these. Well, I take that back. You could only change one. You have to realize, for example, that 2/3 can be made into 9/4 or 9/4 can be made into 2/3. Okay. Which kind of like works better for you? Like, which do you say it? Or maybe you don't see either of them, but like 2/3 is really 3/2 to the -1 power.
Oh, all right.
Okay. And you can get 9/4 to be 3/2 to the power of 2.
Yeah. Wait, wouldn't it be like 3 squared over 2 squared or something?
It is, yeah. I mean that's what it is, but that's going backwards.
Oh.
That's 3 squared over 2 squared gets you back to that. You're trying to get the exponents equal, so you have to have the bases the same. So this is 3/2 to the -x power equals 3/2 to the power of 2. So we know that minus x equals 2. So again, x equals minus 2.
Huh. So negative x equals 3 half squared. All right. Negative x, 2, negative 1, negative 1. X equals negative 2. Oh, okay. On to number 9.
So this one's just putting it into the calculator. If you don't have one, I can get these two.
I have one right next to me. All right.
Yeah.
So
The only thing that might be odd is how to enter this. It's 2 caret square root 10. Your calculator might have the ability to actually show the exponent and the operator in it.
this one turns into 8.9524. Did you
Okay.
get that?
I can check. I didn't have mine handy, but I will get it out here.
Okie dokie.
And getting that up. Okay.
I just make sure I'm putting these in correctly.
Yeah, I agree. So the first one is 8.95.
Perfect. All right.
So we're doing 9. 9 is 8.95. How about, do you have to do 10?
Number 11.
Number 11.
I don't think she wants us doing too many of these. Let's see. I'll put 1 half parentheses and then to the square root of 2. And I have 0.3752.
Okay.
And this, all right, so how much maximum number of decimal places that your calculator displays? That's excessive.
Well, yeah, it's whatever your calculator is.
I'll just, I guess, copy the numbers down. 2142272. All right. Next, number 27, please. Graph each function by hand and support your sketch with a calculator graph. Give domain, range, and equation of the asymptote. Determine if f is increasing or decreasing on its domain.
All right, so there's a lot, like these really have a lot to them that the previous ones didn't, and they don't really even warm you up to it. So it can be kind of tough here. Okay, so I'm reading the list here too. I kind of just want to tell you to graph these on a calculator so we can
move it along.
We can move it along here. I mean, I can draw the rough sketch of this. The rough sketch of this is that it looks something like this. Okay, and you can verify that with a graph. So the domain of these things is always minus infinity to infinity, always. Okay.
Okay.
The range, it depends whether it's one thing or another. It's either minus infinity to the horizontal asymptote, or it's the horizontal asymptote to infinity. So this is if it's going like down. That doesn't actually work because it depends on your viewpoint of it. So the one over here has the range that is minus infinity to 0. How did I know that it was 0? Well, the horizontal asymptote is whatever's being added to it. In this case, it's plus 0. So that's the horizontal asymptote of this thing.
I see what you mean.
The equation of the asymptote is actually should be done first. So the equation of the horizontal asymptote is y equals 0. That's this dashed line here.
All right.
Now, is it increasing or decreasing? I think
this one looks like it's decreasing, right?
It is decreasing.
So it's going down.
Down to the right. Yep. You got it.
All right. 27 through 30. So on to number 28.
Okay, so we're doing all of them here. Let me snip the next one in. I would encourage you to graph these or graph them on your own. So because this number in here is between 0 and 1, it's decreasing. So the graph of this thing, it looks like this.
Okay, so I got a good idea of what it looks like.
It's plus 0. So the first thing I would have you do is figure out the horizontal asymptote is y equals 0, because of that. The domain is always all real numbers. The range this time, though, it goes from 0, which is the horizontal asymptote, to infinity because it's above the x-axis. This function is decreasing because it's going down
To the right?
to the right, yeah.
All right, number 29. So here we got e to the x.
Yeah, so 29,
Is this like ln e to the x?
it is very different. So e has an approximate value of like 2.78, which means that this number is bigger than 1. So it's going to grow. It's going to be a growth function here. So it looks like that. So the plus 0 again. So that's the horizontal asymptote.
Is still y equals 0?
Still y equals 0. The domain is going to be minus infinity to infinity. The range is 0 to infinity because it's above the x-axis.
This looks like it's increasing.
And it's increasing, yeah.
Perfect. On to number 30.
So the other one here, number 30 here, when it says y equals minus e to the x, it's the graph of e to the x, which we just had. Here's the graph of e to the x.
But reflected?
And then reflected. So yours is down here. So again, it's plus 0, so it's very much the same as the other ones.
Domain, negative infinity to infinity. Horizontal asymptote is y equals 0. Y equals 0. And we got range, which is minus infinity to 0, or what is it again?
So what is the smallest value that this function can be? How far down does it go?
To infinity.
Negative infinity. And the maximum it can be is 0 because it comes up and it's the y values. The range is the y values.
Oh, okay. All right. On to number 39 through 42.
Okay, so we don't have to do 31.
No,
Okay.
just 39 through 42.
39 through 42. Okay.
Sketch the graph of 2 to x, then refer to it and use the technique subtracted to. All right.
So do you know what 2 to the x looks like?
I do not. What does it look like?
Well, it's kind of we've been talking about it pretty in depth here. Because 2 is greater than 1, because this value is greater than 1, it's a growth function. So we don't know exactly. It just does something like that. So this plus 1 is on the outside of the function. It's either an up or a down. In this case, it's up 1.
Oh, okay.
So like whatever the graph of 2 to the x is, which we can do right here, it's something like this.
And it's a growth function.
It just every point is moved up, so no, that's not right, but it ends up looking like something like that.
Yeah.
Okay. Graphing tools are going to do a way better job than I can of that. But basically what this section is asking to do is, of these grouping of problems, is do you understand up, down, left, right? Do you have to do 40?
Yeah, 40 and 41 and 42. All right. How do I define it? What does it mean by that?
That just means like, what does the graph look like?
Oh, it's just increasing. Or growth. All right. On the number 40, looks like it'll still be going up though. Even though
It's still 2 to the x, but the minus 4 is that's the horizontal asymptote. So if you were to graph, and that's probably how I should have explained it, is the horizontal asymptote is this line right here.
Yeah.
So 2 to the x looks like this. When you subtract 4, everything just comes down. So it looks something like that.
Oh, okay. X. And then just increasing or growth?
This is a growth. This is definitely growth.
Yes. All right. Number 41. 2 to the x plus 1. Does that mean it just goes to the right?
It's left one.
Oh,
When
left.
when
Never
it's
mind.
plus, yes.
All right.
Yeah, really, they should be asking you for like, what is the transformations of this? How about the last one there?
This one is 2 to the. Oh wait, no, that's 40. Yeah, 2 to the x minus 4.
Yeah. So is it what is it? Is it up, down, left, right, and how
Right.
much? Right.
Right.
How many?
4 units.
4 units. Yeah, exactly. You got it.
I'm gonna check the textbook answers to see what it actually wants, because sometimes it's not very clear. Let's see. We're on 5.2. So let me try to find that. It's basic concept. All right, 5.2. Number. Yeah, it's just wants increasing. Okay. Still find that very odd that it wants that, but whatever. This one's to the right. 4. Increasing growth. All right. Next is 47 through 55 odd.
Give me just a moment to get back.
Alrighty.
Get back to you. Okay. So I'm sorry. Which problems are we up to?
47.
47.
Second. This is like set this up as like 3 minus x equals 3 because 2 cubed equals
That's right.
8.
That's right.
So negative x equals 0. Divided by negative 1. Divided by negative 1. X equals 0 in this case. On the 49. We got 12 to the x minus 3 equals 1. What can I do here?
Which one are you doing again? 47?
49 right now.
Oh,
I
49.
finished number
Okay.
47.
So this one's very different because the bases cannot be made the same, at least the way it looks. You have to remember that to get to 1, it's something to the 0 power.
Oh.
I think you figured that out for me.
X minus 3 equals 12 to 0. Okay. So x minus 3 equals 0. X equals 3. All right. Now we're on the 51. We got 3 to the 5 minus x equals 3 to the 0. So 5 minus x equals 0. Minus 5 minus 5. So x equals 5. Positive 5 in that case. Let's see. How far does one may go? Unless we need to go up to 55. I'm on 53 now. 53. 27 to the 4x. I can do 9, 18, 47. No. I can make this their base is 3.
Yes, exactly.
3, 6, 9, 9, 18. Is it 3 cubed that makes 27?
It is.
Okay. It's 3 cubed times 4x equals 3 squared times x plus 1. I have to distribute. Turn it into 12x equals 2x plus 2 minus 2x minus 2x. 10x equals 2. x equals 1/5.
Yep.
All right, now 55. Let's see. To make that base 2 on the left, 2 to squared, x minus 2 equals 2 to the 3, x plus 3, 2x minus 4 equals 3, x plus 3 minus 2x minus 2x minus 3 minus 3, x equals -7.
Okay.
All right, those were easy. On to 71 through 74.
Okay. So these are all calculator problems.
Okie dokie.
Do you remember going through these? Because there's a certain formula you use for them. I'll snip in 71, of course, so we can go through it.
These are the ones I always end up forgetting, like the
Okay.
differences between.
Yeah, so there's interest that's compounded a bunch of different ways. These are not continuous. There's kind of two forks in these problems. There's either continuous or not continuous. So for these problems, since it's not continuous, it's
A pat or whatever.
PERT. So
Oh,
the
this one's
amount
PERT?
after function of time, P1 plus R over N to the N times T.
All right. R over N times T. Okay. So what we're given is 2,000 times 1 plus, and the rate is 0.03, and that's divided by, what's the number? Is that?
So for annually, N equals 1, and semi-annually, N equals 2. It's kind
Oh,
of that's the number of compounding periods per year.
for semi-annual. All right. All right. So 0.03 over 2 times, that's 2 times 4. All right. All right. Now we got 0.03 divided by 2 plus 1. And then we put that to the power of 8 and then multiply that by 2,000. And I get 2252.99.
20,000 times, let me get caught up to you here. So 0.03, so the annual, and then it's 1 times, and you did it for 4 years. Yeah, that sounds right. And then did you do it for the compounded semi-annually?
Oh, I ended up doing that for semi-annually. I forgot.
Okay, you got to. I
I'm
mean, you
gonna
got to do
do
it
it.
for. You got
Now
to
I'm
do it
gonna
for.
do it for annually. Is
Yeah,
annually like 4 or is?
N is 1 for 4 for annually. Annually means once a year.
Oh, once. Okay, 1 plus. Then it's just, wait. So 0.03 divided by 1. Yeah, so just, so it's 1.03. Then we put that to the power of 4, which is that, times 2,000. So this one should be 2251.
So these are the numbers I get for N equals 1 and N equals 2.
I agree.
Okay, great. All right, so then 72 is the same type of question. It's just different numbers. Like it's not any harder. Quarterly means something different than what we've seen before. Quarterly is 4 times a year. The same formula though, exact same formula. You're just plugging in the different values for the principal, the interest rate, and so on.
Mm-hmm.
So I'll get these numbers calculated for you.
So that's 35K. All right. Wait, n equals 4? Oh, for quarterly. Okay.
Yes.
So divided by 4 and times 4. All right. 39,597.81. All right. All right. On to 73.
73. So again, kind of just, it's like, we got just new numbers. Daily, they actually tell you what it means there. N equals 365. The only other ones that you might ever see are weekly, monthly, and they just have different N values.
Both of them 8 per, or is one of them 8 pat or whatever?
They're both non-continuous, so they're the formula I gave you for these problems are all the same. It would say continuous, and if it was PERT.
Isn't for B it's continuously?
Oh, I'm sorry, I didn't notice that yet. Yeah, it is continuous. So it is PERT for that. So for continuous, it's 27,500. It's PERT, P-E to the RT.
All right. All right, on to 74 for the last one for this homework.
Okay, you said 74. Okay, I got to go to a new page for that. Oh, it's yet another one of these. So just more calculations, I guess. There's no context to these questions. Like normally you would look at them as like comparing. You can put money in two different banks or two different investments, but those options are not here.
4/6 divided by 4. Great temps.
So quarterly means n equals 4.
Mm-hmm.
So for part A, I'm writing down the answer. The continuous one, it's PERT again.
Perfect. All right. All right, now I'm going to take out the next one. Let's see. We got 5.3. Send you a picture of this next one. There we go. All right. This will be 349, 351. I think we'll only get like a small jump on it since we only have like 10 minutes. All right. Should send briefly.
Okay.
Did not work. Should I send that
It'll
again?
come in. I mean, if you send it, it works. I mean, email. We just gotta wait for it to come in. Not seeing anything yet, but check that again. There it is. Okay.
Finally.
Got it there. Right. So 5.3.
Start on number 3, please.
Okay. So we've actually done this before.
Oh, we have?
Yeah. But it's okay. I mean, we can certainly go through it. The equivalent logarithmic statement is, and I have to just write it so that you can see what it is, but it's log base 3 of 81 equals 4. You just have to know where to sort of put these things, get the right positions, and you're either going to be asked to go this direction or this direction in terms of rewriting it for these problems here. You still with me? Are we going on to maybe number 5?
Oh, no, I'm still with you. Sorry,
Okay.
I was just trying to make sure I wrote all the ones that I need to do. All right, so I have 3. Saying to rewrite it. Okay. So rewrite it as log 381 equals 4, like that?
Log base 3 of 81 equals 4.
Perfect. All right, number 5. Let's see. It's just log base 1/2 16 equals 4, negative 4. For number 5.
Number 5 is log base 1/2 of 16 equals negative 4 is your final answer on that.
All right, 7.
Number 7.
Log base 10 of 0.0001 equals negative 4. And then number 9 is how do we put that one? Number 9.
So number 9 is it's no different. It's just, again, kind of knowing where to put the stuff. It's log base e, okay, of
1 equals
1
0.
equals 0. Yeah, thank you. No,
Right.
it's just again kind of knowing where to put these various things. Sometimes, well, not sometimes, log base e is actually ln, but it's okay to actually write log base e. That's how it was done for a long.
I got to number 13. Is it square root 3 to the 8th equals 81?
Yeah, it's square root of 3 to the power of 8 equals 81.
All right. On the 15, 10 to the negative 3 equals 0.001. 17. This one is just what is this? Is 10 to the 0.5 equals root 10.
Which one are you up to? Yeah, 10 to the 0.5 equals root 10. Yep.
Perfect. 19. 5 to the 5 to the x equals 125. That's true. 21. Oh wait, solve each
So
equation.
you actually have to
Give it the
solve it.
exact. All right.
Yeah.
What do I do here?
Well, this one has the variable on the right, so you actually just have to evaluate the left side and use some properties of logarithms like log base 5. 125 is really 5 to the power of 3.
Mm-hmm.
And then you can bring that 3 out in front. 3 times log base 5 of 5 equals x. This right here equals 1. So you got 3 times 1 equals x, or x equals 3.
All right.
It only works out nicely because the variable is on one side of the equation. Usually the variable is in the base, or the thing you're taking the log of.
Okay. All right. On the number 21, how do we solve this one?
Okay, so 21, I'll snip that in. We'll look at it together. Okay, the first thing is that 3 to the power of 12, you can bring that 12 out in front. So it's 12 log base x of 3 equals 24. And then it's multiplying, so you can just divide both sides by 12. So this is really log base x of 3 equals 2. You follow that thus far?
Yes, I do.
Now, how can you rewrite this in exponential form?
Hmm. Oh, okay.
Right? That's what we just did a bunch of. So at some point you have to rewrite it in exponential form. Well, how do you undo that? Well, it's the square root of 3.
Oh, plus or minus. All right. On to number 23.
3.
Log base 6 to the x equals -3.
So now rewrite this in exponential form.
We can do this as 6 to -3 equals x. And 6, what is it, like 36 times 6? What's that? 216?
216, you got it.
So it's x equals 1 over 216.
Mm-hmm.
All right. I got 25. So x to the 4/3 equals 16. How do you solve that though?
So you undo the exponent with its reciprocal, 3/4, 3/4. Because when you multiply by the reciprocal, it goes to 1. So this becomes x to the 1, because 4/3 times 3/4 equals 1.
Mm-hmm.
Now 16 to the 4, 16 3/4, you have to realize 16 is really 2 to the 4th. So 4 times 3 over 4 is 3. So this becomes 2 to the 3rd, which is 8.
Oh.
So quite a few manipulations there. So what do you need to get up to on this?
I was going up to 27. I think this will take us to the end of the lesson.
Okay, you want to do 27?
Yes, please.
We can do it real quick here. So it's the same thing. You're gonna undo the exponent like this. X to the -3 equals 0.001. This is really 1 over x cubed equals 0.001. If you move the x cubed over, you get 1 equals 0.001 x cubed. And if you multiply both sides by 1,000, that will get rid of the decimal. So you have 1,000 equals x cubed. Well, what number times itself?
That's 10.
It's 10. So x equals 10.
Thank you, Matthew.
You're welcome. Thanks for scheduling, and I'll send the notes and the recording out shortly.
Appreciate it. I'll see you
Okay.
later.
Okay, bye now.
Bye-bye.